Hello, this is Professor Brown-Cedarberg, and let's take a quick look at classes and objects. Now, let's define what a class is, and a class is itself a definition of a type. We've worked with the class string, instances of the class string. The class string that comes with the language Java provides a definition of those things that can be considered strings. A class really is a plan or a blueprint. So anything that fits that plan or that blueprint can be considered one of those things. Something that fulfills the plan or the blueprint of a string is indeed a string. And so let's look at objects. And an object is an instance of a class, a specific instance of a class. So when we deal with a specific string, we're dealing with an instance of the class string. A very technical definition of an object would be a thing. A thing that fulfills a definition that all the other things of that type also fulfill. So you are an instance of the class human. You fulfill the definition of a human. My pet golden retriever is an instance of the class dog. He fulfills the definition of that class. He's a thing, one of the things of all those things that are defined in a similar fashion. So, what's a class? Well, a class specifies the members of the objects. And when we talk about the members of the objects, we're talking about first the attributes of the class. We call those instance variables. And then the actions that the class can complete, we call those methods. So when we define a class, we define the attributes of the class, the instance variables, and the actions that instances of that class can complete, the methods. Now, instance variables can be public or private. They can be static or non-static, and they are of a certain type, that is, one of the primitive types, or of a class type. Our methods can be public or private, static or non-static, and any variables that are declared inside our methods have a scope of within that method. They're local to that method. Now, methods may have a return type. They may return something. If they don't return anything, they're void. So they'll always have a return type, but they might not return anything. A void method doesn't return anything. What I return can be of primitive or of a class type. A method can only return one thing. It can have more than one return statement, but once a return statement fires within a method, that method ends. So let's look at a class we'll call rectangle. It's going to represent a rectangle, it's going to have instance variables, and it's going to have methods. So here's our class. Now you'll note that this class has two instance variables. They're both public, they're both ints, they're called length and width. You'll note that it also has two methods, about and area. What's important to note is that it does not have a main method. We define a class in order to create instances of that class. We don't want to run the class per se, so we don't have a main method. So here we have our two instance variables, and then we have our two methods. Notice they're both public. Notice that they're both non-static. A non-static method must be called by an instance of the class in which it resides. A static method can be called more directly by just using the name of the class and then the method name. We'll talk more about that later. Here I have a method about. It's a void method, returns nothing, it's public, it has no arguments passed to it. And what it does is it simply prints out the string. This rectangle has a length of and then the value of length, the string and a width of and the value of width. Now it returns back, it prints out the length and width of the instance of the class rectangle that calls it. Then we have the method area, and it returns back what is the produced when I multiply the length of the instance that called this method times the width of the instance that called this method. So let's see how we call these two methods. So here's our class rectangle. Two instance variables, both public, both ints. A method about that prints out a string, and then the method area that returns back a value. So here's what I do. Here I've got a class called demo rectangle, and notice this one has a main method. This class will run, and I'm going to use it to call the methods of my class rectangle. So the first thing I do in my main method is I create an instance of the class rectangle. And I do that with this line, rectangle r1 equals new rectangle. I'm declaring the type with rectangle. The name of my instance of the class will be r1. I actually create the instance with the keyword new, and then a repetition of the type, and then the open and close parentheses. That's calling a constructor. We'll talk about that later. And then I assign the value created on the right-hand side into the space on the left-hand side. What's actually stored in R1 is an address that points to the space that holds the values of the instance variables of R1 and gives it access to the methods of the class rectangle. I then declare a variable of type int. I'll call area of instance, and I'll then call the method about. But what calls the method about is R1. R1, the instance of the class rectangle. If you recall, the method about is non-static, which means it must be called by an instance of the class in which it resides. So about must be called by an instance. That instance is R1. So R1 calls the method about. About fires and prints to the screen the variables stored in the spaces length and width for R1 for that specific instance. I then call the method area. What's calling the method area is R1, the instance of the class rectangle that I created above. And so it fires, finds the values of the length and the width of R1, multiplies them together, and returns back that value. That value is stored into area of instance. If you have a method return a value, you must store it on its return or it will be lost. So here I have returned back a value. I'm storing it into a space. I then pass what's in that space, area of instance, to system.out.println, and I'll print out the area of R1. So what's important to note here is that I'm creating an instance of the class rectangle. I'm calling it R1. R1 will then call the methods of the class rectangle. R1, an instance of the class rectangle, is needed to call those methods because those methods are non-static. They must be called by a specific instance of the class. And that makes sense because I want to know the length and width of a specific rectangle. And so I want to know that for the area and also to print out the information. So it's for that specific instance of the class rectangle. So what have we looked at today? Well, we've talked about a class. And a class is a definition. We've talked about objects, specific instances of a class. We've talked about instance variables, those values that are storage spaces for types of information for instances of a class. We've talked about the methods, what a class can accomplish, and then specific instance of a class, how to create them, how to use them to call methods within a class. And then how we actually call methods. Remember, a non-static method must be called by an instance of the class in which it resides. A static method may simply be called using the name of the class in which it resides, dot, and then the name of the method. We'll talk more about that in later lectures. Thank you.